Hi everyone, welcome to part 3 of our Python crash course. In this one, we're going to take a look at a few more advanced features, such as the if, else and else if statements, different kinds of loops, as well as a quick introduction to functions. Let's move over into Jupyter Notebook and get started. There'll be a lot of times in Python when you want to execute code based on a certain condition. To achieve this, we can use an if statement. Let's say that we're creating a program to determine whether a person is allowed to ride a particular roller coaster at an amusement park. The program should allow anyone taller than 120 centimeters to ride, but anyone shorter than this will not be allowed. And we can use an if statement to help us do this. We'll start by creating a height variable and we'll assign it with a value of 130 to represent 130 centimeters. To create our if statement, we need to start with the if keyword. So if, and then, is our height greater than or equal to 120 centimeters? And if this is true, we'll print to the console that you can ride the roller coaster. And notice after our condition, we added in a colon, and this signifies the end of our condition. And then before our print function, we have a block of white space, and this is known as indentation. The indentation is needed for our if statement to work as it signifies the code block. Most IDEs automatically enter this indentation for us. If we run the code but purely for our condition, we'll see here that it returns true because 130 is greater than 120, which means that our print function of you can ride the roller coaster will be executed. So if you run our code, we'll get the message telling us that we can ride the roller coaster. Also have an action. Let's go to the bottom of our code, and here we can add in else, another colon, and then our next print, which will tell people that they can't ride the roller coaster. We can see that we can't ride the roller coaster, but if we change our height back to 130 and rerun our function, this person can ride the roller coaster. Let's say though that we want to add in another condition, so that for anyone who is greater than or equal to 100 centimeters in height, will be allowed to ride the roller coaster, but only with an adult. To do this, we can use the elif keyword, which is short for else if. Below our first if, we'll add in elif, and then the condition will be is height greater than or equal to 100. And if it is, we'll print you can ride but with an adult. And if we test this, so with a height of 105, we get told that we can ride with an adult. With a height of greater than 120, we get told that we can ride the roller coaster, but with a height of less than 100, we get told that we can't ride the roller coaster. Okay, so that is how we can use the if, else and else if statements to execute code based on a condition. If we needed to, we could add in more conditions here, but I'll leave it at 3. Next, we'll have a look at loops. Within Python, there are 2 main types of loop, and these are the for loop and the while loop. The for loop can be used to iterate over a sequence, so for example, any of the data structures that we looked at last time, or just even a regular string. We'll go ahead and create a list of numbers, starting at 1 and then going up to 10. We could then use a for loop to do something to each element inside of this sequence. For example, let's say that you wanted to print out all of these elements individually. Instead of manually writing out a print function for each index of this list, we could instead use a for loop to do this automatically for us. To start our for loops, we need to use the for keyword, and then we'll have to provide a temporary variable name. And this can be anything you want, but I'll just call mine number. And then we have to provide the sequence that you want to iterate over, which in this case is our numbers list that we just made. And then we'll finish this off with a colon, and our code for this for loop will just be to print the number. And then if we run our for loop here, we'll see that it prints out each number from our list without needing to manually create a print function for each index. As mentioned, the number variable that we created was just a temporary name, And this name could be literally anything you wanted, even if it's unrelated to the code. So for instance, I could go ahead here and set this variable to be called potato, and the code would still work just fine. It doesn't matter what the variable is called, but it is still recommended to give this variable a descriptive and relevant name so that the code is easier to understand at a later date. Also, the code that we execute inside of our for loop doesn't have to be related to the items in our list. So we could just print out a string for however many items are in that list. There will also often be a lot of times where we want to perform and go through a loop a given number of times. To do this, we can use the range function, which is a built-in function part of Python. Let's create a new for loop here. So we'll have for I, and I is a very common placeholder name for our for loops, which is used in lots of different languages. And then we'll have in range of 10. And then the code will just print out the value of I. If we run this, it'll print out 10 different numbers starting from 0 and then going up to 9. I'll now show you how to loop through a dictionary using a for loop. I've gone ahead and copied over a dictionary from the notebook file for this lecture. So if you want to follow along, you can find the dictionary here, but if not, then please feel free just to watch. Our dictionary contains some information on a student, including their name, age, grades, and courses. And I'll now introduce a new dictionary method called items. Unlike the keys and values methods we looked at, which only return the keys and values of a dictionary respectively, the items method returns the key-value pair, as you can see here. And then we could use this method in conjunction with our for loop to print out the contents of our dictionary. Let's start by initiating our for loop, and then this time we'll have to provide 2 temporary variables. The reason for this is because our items method returns 2 objects, the key and the value. So we have to provide 2 variables to store these objects. And I'll just call them key and value. And then in student.items. And then for each item, we'll print the key and then the value. And this looks okay, but we could improve it with the use of an f string that we've looked at in the first lecture. We'll delete the 2 print functions, and instead we'll create an f string which will print our key variable, a colon, and then our value variable. And now we have a nicely formatted output with each of our keys and their associated value. Let's go ahead and move on to the next type of loop, which is the while loop. The while loop allows us to execute a set of commands until a condition is met, or until we hit a break. To start with, we'll create a variable called I, and then we'll set this to be equal to 1. And with our variable created, we can say that while I is less than 10, then just print I. And now, before we run this code, it's very important to add in an increment for our I variable. Otherwise, I will just remain at 1 forever, so the loop will never hit a stop condition and will run forever. And this is often referred to as an infinite loop. And this is just a loop that runs indefinitely without ever reaching a terminating condition. So at the end here, we'll just add in I is equal to I plus 1. Or a shorthand alternative to this is I plus or equal to 1. If we now run our code, it'll print out from 1 to 9. So to start with, I was equal to 1, so it printed 1. And then we went through and incremented by 1, so I became 2. The program looped again, as I is still less than 10, so we printed out 2, and then incremented again, so I became 3. And this process then repeats until we get to our final increment of 9 to 10. At this point, when I is now 10, when we come to evaluate our condition here of is I less than 10, it'll return a false, as I is no longer less than 10, so the loop stops. Just to show you, if I comment out our increment code here with Ctrl+// and then run the cell, we'll see that we now have an infinite while loop, where I is forever equal to 1, so our print and loop never stops. To fix this, we can come up here to our kernel tab, and then just click to restart our kernel. As mentioned, the other way in which a while loop will terminate is if it hits a break statement. Let's create another while loop here as an example. This time, we'll say that while I is less than 20, we'll print out the value of I, but this time, we'll include an if statement as well. So we're now combining an if statement and our while loop. And we'll say that if I is equal to 17, then we'll break. And again, at the end here, we'll make sure to add our increment. If we run this cell, we'll now see that our code only runs up to 17, because as soon as it reaches this value, it hits our break statement and then it exits the loop. If we moved our if and break statement up above our print function, then it would stop at 16 as the loop exits before print is called. Now that we've covered loops, let's have a quick introduction to functions. In Python, a function is a block of organized code that can be reused to perform a specific action. They form an important part of a principle in programming known as DRY, or do not repeat yourself, which aims to reduce repetition of information and code that's likely to change. To create a function, we'll need to start with the def or def keyword, which is short for define. And this keyword allows us to define a function. Let's create a function that will take a number, square it, and then print the result to the console. We'll go ahead and enter our def keyword, and then we can enter in the name of our function. So we'll go ahead and call this square number. And after this, we need to open a set of parentheses, and in here, we get to provide our parameters. Parameters are basically just placeholders for values that will be passed into the function when it's called, and they allow functions to accept input data and then perform operations on the supplied data. For our example, we want our function to square a number, so therefore we'll need to define a parameter here so that we can pass in a number to our function. Like with our loops, we can call our parameter anything that we want, but again, it's recommended to keep the name relevant and descriptive, so I'll call mine number. Below this, we can then enter in the actual code for our function. So we can just go ahead and say print number and then to the exponent of 2. And this is a very simple function, but let's go ahead and call it. So square number, and then in the parentheses, we'll supply our argument. So I'll enter 10, and then if we run code, we'll see that it prints our number to the power of 2, or squares it, which is 100. We could change our print to include a message too. So I'll create an f string, and then we'll put in the raw number, so just the parameter name inside of our curly brackets, and then the text of squared is, and then inside our next set of curly brackets, we'll put in our number to the power of 2. It's also possible to provide multiple parameters to our function as well. Let's create a new function that allows us to provide a custom number for our exponent instead of just a fixed number of 2. We'll start again with the def or def keyword, and then we'll name our function. So I'll call mine exponent. For our parameters, we'll provide both the number and then the exponent, just separating both of these with a comma. So like before, where we just printed our value to the console, it's actually better to return the value, as this way we can store the result of our function to a variable. And I'll now show you what I mean by this. Instead of calling the print function to print our value to the console, we'll use the return keyword, so now our function will return a value instead of just printing. We just need to return our number to the power of our exponent like this. Let's then create a variable called num_output, and we can say that this is equal to our exponent function with two parameters of 5 and 2. If we print this variable, we get our correct output of 25. And the benefit of doing it this way is that we can now perform other code or comparisons on our output. So for instance, we could perform some logical or Boolean logic on this variable. And one thing that I'd like to explain to you is how the order of the parameters works. When we made our function, we specified two parameters, number and exponent. And then when we called our function, we provided it with two arguments, 5 and 2, which gave us an output of 25. And this is because 5 to the power of 2, or squared is 25. If we had passed in these numbers in the order of 2 and 5, this would actually be 2 to the power of 5, so we would get a result of 32. So the order in which we pass in our arguments will correspond to which variable gets assigned to which parameter. We could also explicitly say that our number parameter is equal to 5, and then our exponent parameter is equal to 2. But normally, you just pass in your arguments in the way that makes sense for your function, or the way that they're listed as parameters. Finally, we'll add in what's called a docstring to our function. And this is basically just some documentation explaining what the function does. To create our docstring, we'll add in an opening set and closing set of triple quotes. And basically, in Python, triple quotes allow us to create large strings that span across multiple different lines. In here, we can provide a description of what the function is and what it does. And the purpose of this function is just to exponentiate a given number. So we can put that inside of our string, and exponentiate just means to raise one number to the power of another. And just to show you, as mentioned, our docstring can span multiple different lines. If we run our function, we can see that nothing has changed with the output or what it does. We still get the exact same result. But what has changed though is the documentation that's available for this function. Jupyter Notebook has built-in functionality that allows us to view and access documentation for a particular function inside of our notebook. If we enter in the name of our function and then press Shift plus Tab at the same time, that will open the documentation window. At the top, we get a signature which tells us what arguments this function expects to receive, but then below this we get our docstring, which provides us with an explanation of what the function does. And this here is exactly what we wrote into our docstring up here when we defined our function. So the Shift Tab documentation is very helpful and can be used not only for our own functions, but also for other functions that are available either inside of Python or many of its libraries. If we take our print function, for example, we can access the same Shift Tab documentation window, and here it'll provide us with information on what the function takes as an input, as well as a description of what it does. So if you're ever unfamiliar or can't remember what a function does, you'll be able to find information on it from in here. And very quickly, before we wrap up this lecture, let's go over another example of a function in PowerPoint so that we can really understand the structure and syntax of functions. And here we have a function that is designed to calculate the area of a rectangle. We start off by calling our def or define keyword in order to tell Python that we want to define a function. Then we need to provide it with a function name, which I've done here and called it calculate rectangle area. And then our function has two parameters, which I've called length and width. Parameters are just temporary placeholder variables that are added to a function so that we're able to pass values inside of the function. Below this, we have our function body, or the code block, and this is the actual code that the function will perform when it's called. And here, we just have it calculate the area of the rectangle by multiplying the length and the width, and assign that result to a variable called area. And then the return keyword outputs the result of the variable, and then terminates the function. Finally, at the bottom, we call or run our function by typing in its name and then opening a set of parentheses. Within these parentheses, we then pass in our arguments, and these are the values that we want to pass into the function. So the parameters are basically what we set up and create when we define the function up here at the top, whereas the arguments are what we pass into our function when we call it. So this is an important but subtle distinction between the two. And then finally, we just assign the result of our function to a variable called rectangle area, which in this case, this variable would be equal to 50, as our length of the rectangle is 5 and the width is 10. So assuming that this is in meters, we could say that this rectangle or this variable has an area of 50 meters squared. Okay, and let's leave this lecture here for now. In the next one, we'll have a look at lambda functions map and filter, as well as how to import modules. Thanks everyone. See you in the next lecture.